Hello, it is Joel. I want to show you how it is possible to convert classic air to strand air in VWD. To do this tutorial, I'll use Xenia air made by 3D and Mairy, and I will use this beautiful air to see you how it is possible to make them more realistic and better for simulation. To show the original air, here is there, it's really beautiful, and I will show the result in a rendering and render. I will use better settings for the render. I will use VWD, this one. Okay. The air is not very well placed on the character, but it is not very important. The result is very good, but there are some transparencies in the air, and it is difficult to do a simulation using this air, to have a very good simulation. I return at the classic view. I remove Genesis 2, and I will show the structure of the mesh. Yeah. Okay, I show the structure. Yes, it is possible to see how this air has been made using small bounds of meshed bonds. This air has a gap too. Here it is possible to see it here. Okay. Now I want to convert this air in strand air. Each line composing the bonds will be converted to a wire composed of small triangles. To do so, I will start VWD. In this screen capture, there is an issue. The application is shown at the center of the screen and not on the right of the screen. Not a real problem. I use the air and I import it as close. I will use minimal settings, no self-collision, no reedification, no stiffness. I apply. Okay, the air is imported in the viewport, in the viewer. Now I will start the conversion. The conversion is fully automatic. To extract the strands, it is necessary to cut each bond in an independent part of the air. So it is necessary to cut the mesh in elements, and then I want to apply the conversion of each to generate strand air for each bond. It is possible to use the two functions, but it is easier to press on the control key and make the cut and generate the strand air using the same this button. I start the process. The process extracts the different bonds, and at the start of the process, it is not possible to know how many bonds elements will be generated. So the best way is to display the number of vertices that stay to be processed. It is the only things we can know. So it is made here in the interface. The process will generate at the end one bond made by triangles to generate volumic air, real strand air. It is important to remember each vertex on the air will be converted to a triangle. So there are also two small boxes, odd items and odd strands, which allow to only take one item on two to limit the number of generated strands, and it is possible to use the odd strands to limit also the number of strands, and in this case one on two will be generated, not exactly one on two. If here the bond is made of 5 elements in the width, so the first, the third, and the fifth element bond will be generated. You can see the process that progress. This function will use these two features in the program. So at the end of the element generation, the program will stop and will restart immediately to have in the list box all the elements generated by this function. The goal is to select the last one and execute the strand generation. The strand generation is very, very fast, and it is not. You will see it. Here is the strand generation, but after that, it is necessary to import all the strands in the studio, in the DAS Studio scene. You can see here the importation. You are here the item. This value decrease, of course, and for each item you can see the strand, the generated strands. This process is only one script, one DAS script, which is executed. But of course, it is necessary for DAS Studio to make a lot of work to import all these OSH files. The generated strand will be closed as the triangle will be closed at the bottom of the strand. At the beginning of when I wrote I start to write the function, I let the two sides opened, but then it is very difficult to select the vertices I want to use for the simulation, the vertices which have to be tied to the character. So, using this method, it is easy to select these vertices using free edges. And this works very well. We are at 60. When the strands are generated, it is necessary to have a band composed of quadrangles, but all the quadrangles must, all the band must have to have the same number of quadrangles on the length, on the width. If the structure is not good, the strand will not be generated. Yeah, you can see the result. And you can see all the strands. All these elements are strands. And you can see the cap has not been generated as strand. Now it is necessary to. It is not easy to use this air like it is here. So it is necessary to export it as only one obj file. So I export the scene in Xenia air to the first. There is already one. I export it. I don't want to generate the surface, the groups. I use only the faces, the normals, on the UV coordinates, and of course the vertices. I export it. Then I will create a new scene. I don't want to save. Okay, now I import the Xenia R2, and I only import the vertices, of course, the UV coordinates on the faces. Okay, here is the result. Now it is on one object. I return to. I will use. Okay. I will return here. Okay. Now I want to see the results with this new air for render. I will apply. I restart the rendering. But of course, it is not perfect because the air has no texture. I apply the render settings, and now I will apply the texture on the air. Okay, you can see the results are good enough because now the air has a volume because it is composed of strand air. We can go at here. I don't know if you can see very well, but it is correct to see. Okay, you can see the results. Now return here. Okay. Now I want to do a simulation with this air. So if I apply a pose or an animation on Genesis 2, of course the air will not move because there are no relations between the two actors. I will restart the texture shader view. I will change the parent of the new air, and I will apply the head of Genesis 2. There are shift, but it is easy to correct it by applying the default values. Okay. Now I want to, if I can apply a pose to Genesis 2. Okay, the result is this one. Okay, it is correct. I can apply make a one ring. There is a light in front of the tunnels, but it is better to shift a little bit the camera. Okay, the result is correct, but I can put it here. Okay. Okay. Now I want to do a simulation. So to do simulation, I can start VWD. Which is at the center of the screen. I import Genesis 2 as collision object. And Xenia air as air, but using the assistant. Okay. I want to do a static simulation. So static, medium length, wavy, and soft. I cannot use the cap because there are no cap. So I have to select the free edge only on the top of the air, and I can use an extension, simple extension to the air, like this, for example. And I want to stiff a bit this part of the air to keep the shape. So I will use, but I want to use more. Okay. And I want to use hard stiffness. All is ready, but there are some strands inside the body of Genesis 2. So I will remove the direct start, and I press on I select the vertices. I add the vertices to the tab, and I start the simulation. The first part is the stiffness of the strand along the structure, and this part. And the second action will be to generate the strand between the strand by neighborhood. Okay. Then the stiffness for the shape, keep the shape of the. Okay. Okay, this is good. As there are some interpenetration, I want we have the risk to have the air to explode. So it is necessary to remove the inertia at the beginning, and then the inertia will be. You will see. I start the simulation, and the air are okay. Now it is good. I can set the inertia again. Okay, you can. I can remove this part, and I can start the. Okay, now I can send the pose to the host to see the result. It is correct. I can make that several times to see the result. Okay. Now I want to apply small wind, or middle wind, for example. Yeah, you can see the result. The air move. I can one at a time. Okay. Then I can remove the wind and the air. I can do the result. You can see the here. So we can consider this result is what you want. We can stop VWD, and then you can see the final result. You can let the render program finalize the image, and you can see the result in the interface. Okay, I hope this tutorial will be useful to you, and this function is not ready in VWD for now, but we will, with Dan, we will find a way to implement it in the program soon. Okay, I thank you for watching. Bye.